Hello and welcome to Technical Utkranti, and today we are going to see the 6th question on linked lists. Overall, it is going to be the 31st video in our DSA series. This is going to be a small video and very simple solution exists for the problem that we are going to discuss today. I highly encourage to visit the link for the question and solve it yourself and then look at the solution in the video. The link for the question is available in the description. Let's have a look at the thought for the day, and I hope it inspires you to develop a better mindset. These are the questions that we have done till now, and let's jump straight to understanding the question. We are given a linked list and a node in it. We have to delete that node in O of 1 time complexity. So this is a linked list. Node to delete is 4 and the output would be 2, 3, 5 because 4 is deleted. Now let's jump to understanding the approach to the question. We have this linked list over here and the node to delete is 4. How are we going to delete it? Usually what we do is we traverse from here and find the node, and once the node is found, from the node previous to that node, the link is modified to point to the next node, and in this way we bypass the node to be deleted. Alright, but this is O of n approach and this is not what we want. We want O of 1 approach. Now how are we going to do it? We have this node over here, and for linked list node we know that it has two components. One is the value itself and another is the next pointer. This next pointer points to the next node. In order to delete this node, we need to ensure that instead of this node we come directly to this node from this particular node. So what we do is we just copy this node to this node and delete this one. Now let's see how are we going to do it. What we'll do is for this node value, we'll update it with the value of the next node. So how are we going to do it? Node is this node only, but node.next becomes this node, and when I do node.next.value, I get 3. In this way I update the value, so this becomes 3, and then this linkage also has to be broken and pointed to 5, right? In order to do that, we'll update this to node.next, which is 3, and .next again, which is 5. In this way, both the next and the value part of the node are made similar to this particular node, and since this node is broken, when we traverse the linked list from 2 it goes to 3 and then it goes to 5. This node gets deleted or bypassed. In this way, just in O of 1 time complexity, without having to traverse and finding the node to be deleted, we actually end up deleting the node. So this is the approach and this is the pseudocode. Let's see the Python implementation of it. So here I have written the method for deleting a given node. I am just updating the value and the next pointers as I had shown in the approach. So I hope you liked the video. If you did like, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye. Goodbye.